Right. Basic of logic gates I have given. So when you have, okay, let's use some. I'm going to demonstrate using actual logic, logic virtualization. So this one I think okay, no? Converting from decimal to binary by dividing and writing the remainder, and converting from binary to decimal by taking the
Yeah, sir.
positional value. You have to take the positional value and multiply
Yes,
by
sir.
the positional value and add it. Clear?
Yes, sir.
Right, okay. So if you are clear on this, the next thing is logic gates. Logic gates also you should know at least the basics. Then only we can do these things. Otherwise in programming again, we will struggle. And here, basically if you have not logic, so what's happening in the not logic, it will invert. For an example, let me use a switch to demonstrate this and a bulb. Here you can see switch is not turned on, but bulb is lighting up. Why? Because this not gate. Not gate will invert. When it is 1, it will be 0. When it is 0, it will be 1. Okay. So basically, this is the truth table. Yeah. When it is false, it will be converted to true. And when it is true, it will be converted to false. I think you know this because all level ICT also you had this. And AND gate, so AND gate, in order to lighten up this bulb, all should give 1. If both are 1 only, this is 1. If both are 1 only, this is 1. If there are 3 or 4, all 4 need to be 1. This one and this one also should be 1. If there are 4, all 4 need to be 1. Then only it is 1. So that is the easiest way to remember AND gate. If all are 1, it is 1. If at least 1 is 0, it will become 0. Understood?
Yes, sir.
Okay, then OR gate. OR gate behaves the other way. If both are 0, OR gate will be giving 0. Forget about this multiplication and all because it will, the multiplication kilo some place it's difficult to figure out because you have to it's like multiplication, but it is not exactly the same. It has different meaning, right? Forget about that thing and just try to learn in this way. And OR gate, if both are 0, it's 0. If either one become 1, it will 1. Make a 1 unat 1, mea 1 unat 1. If both are 1, again it's 1. That is OR gate. So assume that there are 3 inputs or 4 inputs. Let's say 4 inputs. If there are 4 inputs, all 4 should be 0. Then only this is 0. All this is the one that you have to remember, right? Here all 4, if all are 1, this is 1. If all are 0, this is 0. Understood? Hello?
Yeah, sir.
Right.
So yeah, all four, yeah, all four.
All 4
Oh
0.
no, for this, if anything, right?
Anything, if anything become 1, this one or this one or 2 of this or 3 of this or either 4 of this, doesn't matter. Don't think about that occurrence because easy to remember when all are 0, it's 0. All other occurrences, it's 1. No? Here, if I get the logic of this one, let's
Yeah.
highlight and get the truth
So
table.
is this a free website?
Yeah, this you can use this for demonstration purpose. Here you can see this is the logic.
So yeah.
All are true, all are true. But in one occurrence here, when all are false, it's false. When all are 0, it's 0. Understood? But all other occurrences, don't worry about that. All other occurrences, it's 1. No doubt. Right?
Okay, sir.
All are 0, it's 0. Here the other AND gate is the other way. AND gate works the other way. Yeah. Sorry, I have to select all. AND gate works the other way. If all are 1, it's true here. True, 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 then true. Otherwise false. All other occurrences is false. Okay, remember like that, then that's very easy to solve questions. Then XOR gate. This is XOR. Exclusive OR gate. So it's odd even one. It's odd even one means if you have this kind of thing, if you're using this kind of thing, and then if you use both 0, it's 0. Odd. 1 is there, it's 1. 1 is there, it's 1. Odd. But both are 1, then it's even. If it is even, this is 0. Right? So maybe in your, so are you going to any other classes, whole classes or so? For IT, no?
No, sir.
Right.
Sir.
No, I'm not going to.
Right, okay. So sometimes in the classes, you might learn something like this, right? So here, in some classes, they teach like this, but so if both are similar, that is 0. If both are similar, 0. Here both are similar, it's 0. If both are different, then 1. Different, then 1. Different, then 1. But both are similar, then 0. But don't remember that. That's false. The reason is this. What happens if you have 3? What happens if you have 3? Okay, if you remember that logic, if all are similar, it's 0. Then if all are similar, is it 0? It's not 0, it's 1. Right? So, but this work in odd even way. Okay. So tell me this. If there's a 1, is it odd? එක 1 එකක් නම් තියෙන්නේ odd නේද?
Yes, sir.
If there's only 1, it's odd. Then it is 1. If there are 2
Only.
1s, then it's even. If there are 2 1s, it's even. So off. If there are 3 1s, then it's, yes, if there are 3 1s, it's odd or even.
Odd, odd.
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 Then
Okay.
so that's the easiest way to remember. So if there are 5 inputs, let's say, if there are 5 inputs,
5 means odd.
if there are 5 inputs and all 5, I'm going to connect
Odd.
this.
Odd.
And yes, this one. So you can answer this way. You can answer for any number of inputs. If there are 5 inputs, all 5 connected, and all 5 turn on. That's one. 4 out of 5, 0. 3 out of 5, 1. 2 out of 5, 0. 1 out of 5, 1. 0 output, then it's 0. So it's taking on whether it's considering whether the number is odd or even. Understood?
Yes, sir.
Okay. So this is how the basic logics work, but this is not a logic gate lesson, right? So because in logic gate we have to learn more than this, right? We have to learn like flip flops, combinational logic gates, and much more to learn. Okay, then let's go to our. So then the last one is not. So okay, what happened if you give not 4? Not 4. What will happen? Not 4. Yes.
Then not 4. So 0.
Not 4 is minus 5.
Minus what?
5. Yes. Not 7.
Oh.
Yeah. Not 7 is minus 8. Right. Not 10 is minus 11.
Oh. Minus 1. Added.
Yeah, minus the 1 will be added. So, but remember like this, but there's a reason for this, right? So since you have not learned the binaries, I cannot explain the reason, then you will confuse.
Hmm.
Right? If you want, I can explain why what's happening. Have you heard of this 2's complement numbers?
Oh, yeah.
You heard of
Yes, sir.
What's
in
that?
school? In school or where you learned that? In a
The
class?
class.
In a class. Then you can understand that. So what's happening when you say not 7? 7 is 111. Sign of this is 0. Right? Because it is plus, no? Plus 7. So if you have 8 bits, you can write like this. 0, 0, 0, 0. The first bit is sign. So 0, 0, 0, 0, 0, 1, 0, 1, 1. So this is 7. But if you not, what will happen? It will be converted to 1, 1, 1, 1, 1, 0, 0, 0. Because not get will invert, no? All 5 zeros will be inverted to 5 ones, and then 3 ones will be inverted to 3 zeros. But computer will treat this as a 2's complement number. So if it is 2's complement number, how you convert it to normal number? If it is,
By adding 1, right?
yeah, you have to invert and add in 1. Invert this
Yeah.
number without the sign. Excluding the sign, you keep the sign as this is, but invert the number. Invert the number means then 0, 0, 0, 0, 1, 1, 1, and add 1. So then it will become minus. Here 1, 1, 1 is 7. 7 plus 1 is 8. This is what happened. So if you know 2's complement, you can understand. That's why it has become minus 1. So if you
Yes,
really
sir.
know the 2's complement concept, you can understand what's happening over there. Because when you ask to invert, it will
Hmm.
not consider about the sign. It will invert. But after inverting, computer will think this as a 2's complement number. So computer will display it to us by inverting and adding 1 with the negative sign. That's why it has become minus 8. Okay.
Okay, sir.
Okay, that's why I said you need binaries, you need logic gates, all these things to learn programming, because how actually computer works according to these binaries and logic gates.
Yeah.
Right? That's why in programming we have to know those things. Okay, now you know why 1 is added to this, right? Because of this 2's complement reason. So in the other hand, if you not minus 11, what will happen? If you not minus 11, you will get plus 10. So that is the reverse. The minus number, you have a minus number, you invert it, then it will be, so here this is minus 8, no, you invert, you will get plus 7. Hopefully you can remember that. Okay, with this part, the operators in, yes, this with this part, the operators in Python is over. You will get a few questions from operators. Then we have to move to the second concept of programming, that is selection. Okay, second concept or second control structure of programming, that is selection. Okay, for that, please write down this question. Draw a flowchart. Draw a flowchart. Write pseudocode and Python codes to display whether an integer input is odd or even. Draw a flowchart, write pseudocodes and Python codes to display whether an integer input is odd or even. Okay, I'll give you 5 minutes. Just try this out. I'll give you 5 minutes. Can you try this? If you have questions, you can ask.
Okay, sir.
First of all, you have to input this. You have to start and input a number. So this is the symbol for starting. Can be rounded rectangle. And then you have to input the number. That should be input integer number. Let's add input integer number. Let's say it's num. After inputting, you have to check whether, sorry. After inputting, you have to check whether this number is odd or even. To check that, I am using a decision symbol. How to check whether odd or even? Basically, if that number modulus 2, if it is equal to 0, after dividing, if remainder is 0, then you can say this is even number. You can print display num is even. If not, you have to display number is odd. Number is even. If not, number is odd. Here you have to tell that if it is yes, you do this one. If it is no, you do the other one. You have to add the labels, yes and no. Labels, yes and no. And here you have to add the arrows to show the data flow from start to here, then from that to the decision. After that, what you have to do, you have to connect this both ends. Just connect this one and this one. Using a connector symbol. Connector is a circle. Okay, after connecting, you have to finish. It's very simple. After finish, you have to stop. And that will end this program. Okay, so if you have come up with this, and that is the draw a flowchart, pseudocode, and Python code to display whether integer, whether an integer is input. Sorry, whether an integer input is odd or even. So you give integer input, and this will print. This will divide by 2 and write the remainder. If the remainder is 0, it's odd even, and remainder is 1, it's odd. So this is the program. So have you drawn something similar or anything else?
Similar, sir. Similar.
Similar. Okay. So then what is the flowchart? Pseudocode. Pseudocode you can write like this.
Begin. Yeah.
Begin. Then you can say input
Input.
n
Integer.
so this is integer, and then you have to tell that x sorry, this if num
Divisible
module
by 2.
is equal to
Divisible, no?
modulus, no? Modulus 2 equal to 0.
Yeah.
So after division, after dividing, the remainder is 0. Then
Okay, sir.
you can say print num is odd, so num is even, else print num is odd. And if an int, then the Python code. That is the one I really need you to write. So let's go to new file. I'm going to input the num, and that number is integer. Let's input just by giving a message, enter an integer number. Then if this num modulus 2 equal to 0, then you have to print num is even, else print num is odd. Then save it. And run it. It will ask us a number, enter an integer number, 45. 45 is odd. Run it again. It will ask to enter a number, let's say 48. 48 is even. So if you use division, it's so how you are going to find that? So when after dividing, it will be an answer, no? It's not remainder, no? If you have used dividing, it will be an answer. For an example, 5 divided by 2 will be 2.5. So using 2.5, can you decide? Using 2.5, can you decide?
No, sir.
That's why I said not to use division, right?
Uh-huh.
Okay, please write this. So please write it
Okay.
in the in a computer or phone.
Okay, sir. Hmm. Sir, can you also scroll it a little bit up? Yeah. So I can take a screenshot.
Previous one.
Yeah, sir. Little bit up. Yeah. Okay, sir. Nice. Okay, sir.
Okay, no? Right. Then write another question.
Huh?
Okay. Write this question. Write a program to input 3 marks. Write a program to input 3 marks. Then find the total and average. Then find the total and average. If average is greater than or equal to 75, assign grade as A. If average greater than equal to 65, then B. If average greater than or equal to 60, sorry, if average greater than or equal to 55 and less than 65, then it's Z here. If average greater than or equal to 65 and here and less than 75, then it's C. If average greater than or equal to 55, sorry, 45 and less than 55, then it's S and F otherwise. Print total, average, and grade. Okay. So
Yeah,
please
sir.
do,
Sir, this
yeah, please do
homework, right?
this one as homework here.
Okay, sir. Sir, can you show me the Python code
Oh,
for a bit?
okay. The last one. Okay.
Okay, sir. And sir, we did the homework you gave last week.
Last week. Okay. Can you
Yeah.
send it to WhatsApp?
Ah, okay, okay, okay.
Okay. Please send a screenshot of that to WhatsApp. Then I can.
Okay, sir.
Okay. Then
Okay, sir.
see you on.
Okay, sir. Thank you.
Okay. Bye.
Thank you, sir.
Thank you, sir.